How do you teach a car to drive? Some people might think that what you do is you give it all these rules about driving. You tell it all these, well, if there's a car a little bit over there, you should give it a little bit of space. And, if there's and there's all these like very rigid rules, like you should stay in the exact center of the lane. But this isn't how humans drive. This might be how humans think they drive, but it isn't how they actually drive. So how do humans learn to drive? Well, they watch other people drive. And then they try it and they get better. And that's exactly what we're doing here. So right now we're just in the watching phase. We have not told this car anything about driving. We've shown it 10 hours of human driving footage, and we're like, here is what the human did. Behave like that human as much as you can, right? And you get all this intuition that you'd never get in a rule-based system.
This is round 3, 10 hours of the car learning to drive. Does it drive like a person that's been driving for 10 hours, or is it better than that?
It's driving like a person that's been driving for 10 hours, which you'd be surprised, there's a lot between that 5 and 10 mark.
So the car is now just totally driving by itself.
The car is completely driving by itself. You want the car to start modeling the people around it.
Okay.
You want the car to know what people are about to do. The point is to drive naturally like a human, not like some engineer's idea of safety in a building. When you get on the highway, press this one, and always remember, if you don't like what the car is doing, press cancel. It'll give you full manual control back. Go ahead.
Here goes nothing, man.
Press it.
Good?
Yeah, good. Let go.
Jesus. That is amazing, man. It is hard to commit yourself that this is going to work.
I know. He's very safe following distance to the car in front of you.
This is driving, man. I gotta be honest. I mean, I didn't think it was gonna be that good. When I drive with you, usually it's just really hard for me to tell.
For you to tell how much the computer is doing. Exactly why I wanted to let you drive.
That is crazy.
Hot still has a ton of work ahead of him to prove that this technology can work. But spend an afternoon with him, and you can't help get the feeling he's on to something fantastic, and that this may be a huge breakthrough, not only in self-driving cars, but also for artificial intelligence technology.
I think that a lot of companies today are just, they're just doing a really poor job. And I might be way off base. There might turn out to be a reason why everyone does what they do. Sometimes I've seen that, but sometimes I've seen it just took a new set of eyes to come in and be like, hey, wait a second, we can do everything better. And really what it's all about too is it's about having fun. It's not about, I'm never gonna say that we're changing the world. I mean, we are, but that's not like, that rhetoric has been hijacked. What this is about is actually building really cool things that we want in the world.
want to live on this planet anymore. And you know, Mars is not exactly inviting looking. Is it really possible that there are no other readily habitable globes in the heavens? Surely there's one out there somewhere. For every grain of sand on Earth's beaches, there's at least 10 stars in the universe. And you figure there's at least one planet on average around those stars, if not more. So there's going to be more planets than stars. Surely there's got to be something out there somewhere, an extrasolar Earth. So where are all those planets? We need to find them. Scientists are developing new techniques to find these extrasolar planets all the time. I mean, we've got a lot of data, we just don't know how to reliably find extrasolar Earths in the data that we have. It's a tricky problem. One technique involved the development of a coronagraph, which revealed 4 Jupiter-sized planets orbiting a star. Now, this took almost a decade of observations. We don't have that kind of time. Another method is called the transit method. Basically, what this does is it looks for a star, and then it looks for the star to periodically dim. And based on how much it dims and how often it dims, you can sort of figure out how big the planet is, sort of where it is. And the really cool thing about this technique is that you can use imaging arrays and image a bunch of stars all at once. Just take a ton of observations. You can do thousands or tens of thousands of stars, whatever you can fit in a field of view. So this lends itself to numerical analysis, data analysis, big data analytics, or whatever you want to call it, in order to find extrasolar Earths. The problem, though, is that Earth isn't really that big. So the amount of dimming that you'll see from a planet-sized Earth, stars are analog critters. They're going to dim and brighten on their own. Enter the Lowell Observatory. The Lowell Observatory is an independent nonprofit research institution founded in 1894 by Boston mathematician Percival Lowell. It's near Flagstaff, Arizona. Scientists at Lowell University and Yale University have built something they call the Extreme Precision Spectrograph. This is one of the first instruments where scientists actually expected to have the level of precision necessary to locate extrasolar Earths that meet the criteria and that are not super gas giants or anything like that have a pretty dramatic local dimming effect. Now at the Lowell Observatory, they're already collecting reams and reams and reams of data. In fact, they're having a little bit of a data overrun issue. It turns out if you can't process a day's worth of information in less than a day, typically way less than a day, pretty soon you're going to be overrun with data. You're going to be drowning in data. The data really needs to be processed quickly and also distributed to other research scientists around the world. Yale University, they're not just sitting around. They need that processed data in order to do their analysis and research. Data overruns, a giant mess of data, drowning in data. Sounds like they could use a computer janitor. So, I've been talking to Dr. Joe Lama about precisely what sort of computer janitorial services they require, because I am at their disposal. So while astronomers are looking for planets around other stars at night, we still need a good model for how stars behave. I mean, searching for an Earth-like exoplanet around, a star like our sun, definitely needle in haystack territory. So if we had a better model of our sun, it might help us do that. So this instrumentation is used during the day and at night for collecting different kinds of data. Yeah, Dr. Lama is running the experiment for the solar collection aspect of it, and NASA has already collected 2.8 petabytes of information. So the hope is that this massive volume of information might be just the first chapter of an epic tale about human space exploration and finding the first habitable exoplanet. I got a plan, but I got to call in some favors. Yeah. Oh, yeah. Yeah. Well, I mean, it's for a good cause. They're a nonprofit. We could really, we could really get a lot done. Oh, great. Thanks. That's awesome. I really appreciate it. I'm sure they will too. Thank you. Thank you. Thank you again. Good news, everybody. Well, I've got a plan, and my plan is to process that data as close to real time as possible. As soon as the data comes in, process it, and get an indexed, compressed version of the data stored on a high-speed storage array, something like flash memory. Now, we're going to keep the original data on a spinning Rust, hard drive array that is local to the server, so we could pretty quickly, load information from that, mechanical storage. Because hey, 18 terabyte hard drives are a thing, and 18 terabyte flash drives are, those are expensive. So we can reload any data that we need from the local storage array. If we need sort of even more storage that'll fit in a single chassis, because 200 gigabytes a day doesn't, even 18 terabytes doesn't last all that long, or 18 terabytes times 12 drives, we can offload that extra storage for networking. And so in addition to storing the information that we process as close to real time as possible, probably also going to deploy a couple of containers on the server so that other research scientists can make a request, fill out a web form basically, and then be able to get any other information that they need and download it in real time. This is probably going to be an ongoing process, probably going to end up seeing a couple of videos about this and the other stuff that goes into it. So now we wait. Wow, that was stealth. I think it's time for a build. As our Voltron montage implied, Gigabyte and AMD have really contributed generously here. We cannot thank them enough. Without them, this project would not have been possible. And Kioxia also kicked in for some flash storage. We're using their CM6 Enterprise SSDs for our storage array. And we got 4 of them as configured in this chassis, so we're going to be able to process data as close to real time as possible thanks to this flash array. The final build has 2 32-core EPYC processors and 1 terabyte of RAM. Some of you at home have 512 gigabyte SSDs. This computer has 1 terabyte of RAM. Now with this hardware, we can process a full day's worth of data in much less than a day. So we can catch up on all the data that's sort of overrun everything else, and also be able to really quickly reprocess data whenever they change the algorithm. The centerpiece and crown jewel of the plan here is of course the Gigabyte G482. This is a research scientist's dream server. It's for you, a lot of the time the data center, they're after the most compact machine possible. But this chassis is one of the most flexible enterprise chassis that I've ever seen. It combines NVMe, 3.5-inch storage, there's even 2.5-inch SATA storage. And we've also got all the PCI Express connectivity that we'd ever need. Now we don't have an algorithm yet that'll take advantage of GPUs or FPGAs or anything like that. So all of the heavy lifting here is down to AMD EPYC. And the 32-core monster CPUs that we have in this chassis are gonna cut through that data really quickly, no problem. The 32-core CPUs sort of balance high clock speed and core density for sort of the sweet spot for this particular algorithm looking for our extrasolar Earths. Now there's still plenty of room for optimizations and fine-tuning in future videos with level 1, but let's check in with Dr. Lama and find out a little bit more about the Lowell Observatory, his team, and the goings-on so that we can sort of have fun and live vicariously. So I've got Dr. Joe Lama here with me. Hello and welcome. You're live from the observatory.
Hi, Wendell. How are you? Great to see you.
So, this thing is a lot of horsepower. a ridiculous amount of horsepower, and you are gathering data almost faster than we can really store it, because you and I were working together and looking at some stuff and that kind of thing. But walk us through it. Like, what is the deal with this level of data? It's absolutely bananas, and you're using the telescope during the day.
Yeah, I'm doing everything backwards. I'm definitely a social hour astronomer, not a nighttime astronomer. So yeah, when we first started this project, we didn't really think too much about, the computing needs of this. It was sort of, oh, here's a cool idea, let's go do it, and we'll kind of figure out the details later. And in as you well know, those things come back and haunt you. But yeah, we have this one star up during the day, the sun. No, none of my colleagues are vying for telescope time. They all just want to use the nighttime. So I've got unobstructed access to the telescope all day, every day, pretty much. So yeah, and as you say, that generates a lot of data.
Well, I mean, it wasn't just you, though. I mean, it was like I was doing some of the prep material for this, and NASA, and one of the things you sent me is like, it's like, oh yeah, NASA just casually dropped, oh yeah, we've got like a petabyte of data on the sun during, daily observation, and it's like, okay, there's something to this.
Oh yeah, absolutely. So the sun is just, it's so close by. All the other stars you see in the night sky are just these point sources, and while we can collect a lot of data on them, they are still just point sources, and there's a lot of things that happen between us and those stars that prevent us getting as much data as we can on them. So stars like the sun, it's this really cool opportunity to look and just understand what's going on inside these big fireballs. It's really a cool opportunity.
Yeah, I think that we've already been sort of testing the server a little bit with some data sets and running through that, and it really is like a buzz saw just cutting through the data. I mean, AMD EPYC and what Gigabyte has put together in this chassis, they really sort of carry it home as far as data processing in real time and like whatever crazy software and algorithms and stuff like that you guys come up with. It really is crazy to think that this might be the machine that finds a planet where, and it's like, oh, we need to look more closely at this. Oh, we're getting polarized light from this planet. Maybe the plants on the planet are absorbing the other polarization of light. It's possible.
Oh my God, yeah, it's so true. Yeah, we can't thank Gigabyte enough. This is way more computing power than we ever thought we'd get access to, or maybe we'd even need. But when someone gives you a hammer, you find the nail to hit the problem with. So yeah, we will throw everything we've got at this machine. I'm really excited.
It's not just you guys aren't just collecting data for yourselves either in the project. I mean, you've got a lot of other higher education and other researchers that you're feeding the data to. So it's not just, your group this depends on. I mean, there were some pretty big names in there.
Yeah, that's right. So what we want to do is, make this data as open as possible. So all of my colleagues around the world can, download it and have a crack at beating this problem we have of trying to tease out the tiny signals from orbiting planets.
Yeah, you said I think on the existing system that when you're running data processing and like you bring up the terminal, you would type a few things and then like a few seconds later it would sort of go across the screen.
It's like using dial-up internet. That's the thought process I had.
Oh, the load average is 150. Is that good?
Yeah, that's right. Yeah.
So yeah, this does this will cut through that with quite a bit more ease than the existing setup, and we can also scale it. Yeah. So in terms of like making that data accessible and dealing with that on the software side, we're looking at doing that with containers, and that is something that we can revisit in a follow-up video. I'm sure I'm going to try to make it out there at some point. So at some point there's going to be a part 2. Yeah, definitely comment below and do all the thing, and we'll see if we can arrange that. But I would love to come out there and actually see stuff in person and like, let's shred the data. Let's do the consulting thing and figure it out.
Right. And it's really cool having such a powerful machine. It makes you, normally when you want to reanalyze something, you change something in the code and then you have to wait a week to see if what you did works or not. And with this system, we're not going to have to do that. So it's going to, joking aside, it's really going to literally speed up both the data processing, but also the analysis. It's so cool.
Yeah, both sockets are, I think you'll be able to do your real-time processing as normal, But also, when you have an algorithm change, that can be running in the background because, you have months of data, and that's still going to take a while to process, but it's not going to interfere with the daily processing.
Yeah.
And this chassis, because it's got so much PCI Express connectivity, you can also expand the physical disk storage, so you can have inexpensive, locally attached storage. We did our garbage server build, and you could use something like that to add another, 48 3.5-inch bays, and that'll get you in the petabyte range with some reasonably sized hard drives.
Yeah.
And that's local attached storage, so it's automatically really fast. You can do stuff over the network, of course, too. That's just more interconnects, but also FPGAs and GPUs at some point in the future. It's like you've got to invent the algorithm on the CPUs. You've got to do the inventing and the hard thinking with general purpose compute. You can't do it until you figure out what you need with something specialized like a GPU, and that's why these things are so critical to research scientists.
Yeah, that's right. And my colleagues are starting to develop all these machine learning techniques and all these cool applications that we can use GPUs for. So this chassis is going to do it all. Yeah, it's really is going to be my one-stop shop. I no longer have to buy these really powerful desktops. I can get my fancy iMac or whatever and just zoom into it. It's going to be great.
Yeah, it'll be able to run all of their jobs as well. I mean, you might have an office award for the person that comes up with a job that actually bogs the server down.
Yeah, well, that's not a bad one. We could do that competition. I think our IT guys have joked that I think I've got the single most powerful machine, probably in northern Arizona, maybe. So yeah, it's gonna be really cool.
Well, Epic is definitely going to bring home the bacon. There's no doubt about that. So it'll be interesting to do the follow-up. Well, thank you for coming on. It's been awesome. Any parting words of wisdom? Anything you want to check out? The Lowell Observatory is linked below, and you can check out the research. Maybe kick them a few bucks.
Yeah.
A lot of awesome stuff.
We're a non-profit research organization. We're doing the best we can in these trying times. Our tours have just started back up. So if you find yourself coming through Northern Arizona, lowell.edu, and you can book yourself onto a tour. Huge thank you to you and the guys at Gigabyte for making this happen. It's beyond amazing. I'm so thrilled with how it's all worked out.
Oh, and AMD and Kioxia. I called in a lot of favors
I really
to get this thing
appreciate it. I'm gonna have to learn some bargaining from you.
Well, it's pretty easy when you're a nonprofit because you can use the magic words tax write-off. And then, all of a sudden, all the doors open, and it's sort of magical. But yeah, Lowell Observatory, check them out. I really love the work that's being done, and it is really exciting to think about the next, what I always say extrasolar Earth, but it's what do you guys call it?
We just shortened it to exoplanet.
Yeah.
So Earth-like exoplanet is kind of how we say it in the biz.
The next Earth-like exoplanet could be found by AMD Epic and this machine. That is pretty bananas. So it's really awesome to have the opportunity to work on this. So thank you for that.
Oh, well, thank you. This has been a great project. It's been a ton of fun. And this is just the beginning too. So I'm looking forward to more of these.
Excellent. Well, once again, I want to thank AMD and Gigabyte for their awesome support on this project. I love working with nonprofits. If you've got something that you want to do, reach out. Maybe we can work something out. It's been really great. Special thanks to Kioxia for their flash storage array. I'm sure this isn't the first time we're going to see this monster beast Gigabyte chassis in server videos, because it's pretty much the chassis to have in a hyper-converged infrastructure. I mean, it does everything. Be sure to check out the Lowell Observatory, check out their mission, maybe kick them a few bucks. They are a nonprofit after all. I'm Whittle, this is Level 1. I'm signing out. You can find me in the Level 1 forums.
center with 3 OCP racks in which server equipment from various world manufacturers are mounted. This is the second test site in Europe to receive the official right to use the Open Compute project name and logo. By launching this project, we wanted to solve two problems. First, to acquaint the maximum number of specialists with OCP standards and equipment to provide an opportunity to see, touch, test the most modern computing servers and data storage systems. And second, to organize a test zone in which it will be possible to run in combat configurations of hardware and software. Any company that is interested in buying servers can test the operation of their productive software on serial servers by assembling the required configuration. The OCP standards are developed and maintained by the Open Compute project community created in 2011 at the initiative of a group of large computing consumers led by Facebook. The main idea of OCP is to move away from the dictates of large vendors and joint development of technology, similar to how it works in open-source software. First of all, the community rethought the approach to organizing the data center and changed the format of the computing rack. The fact is that the familiar 19-inch rack was invented back in the 20s of the last century to equip telephone exchanges and has remained practically unchanged since then. Technologies have changed a lot over 100 years, and those telephone exchanges are no longer there. However, the racks have remained unchanged. In just 9 years of work, the OCP community has released over 100 new products, many of which have become popular far beyond the Open Compute community. The first difference that catches your eye when looking at the OCP rack is the increased mounting width of the equipment. It is 21-inch, which is 2 inches more than a traditional rack. This gives a 10% increase in usable volume for servers. At the same time, the external dimensions remain the same, which means that the OCP rack occupies the same 60 centimeters and fits into the range of conventional racks without any alterations in the server room. The second difference is the height of the unit. In the traditional rack, it is 44.5 millimeters, and in the OCP it is 48. To avoid confusion, this unit was called the Open Unit, OU. Fans of larger diameter are used, due to which increased cooling efficiency. As a result, OCP servers can operate at air temperatures in the data center up to 35 degrees. The third feature of the OCP rack is that all the power supply of the equipment is brought to the rack level. There are separate power shelves. 2 shelves are installed, but if there is not enough equipment, the one can do. Each shelf has up to 6 power supplies of 3 kilowatts. That is, the rack becomes similar to such a large plate system. At the back, along the entire height, there is a single 12.5-volt power bus, to which the power contacts of the servers are connected. Therefore, there are no bundles of power cables like in traditional racks. And since all network connections are located on the front panel, it turns out that all maintenance can be carried out from the front, only from the cold corridor, never going into the hot one. The power bus is closed against accidental short circuit and is absolutely safe for humans. By standards, the maximum human-safe voltage is 60 volts DC. Here, let me remind you, we have a voltage of 12.5 volts. All servers and storage systems are toll-free and snap-fit. In general, the OCP ideology implies that any installation or replacement of any spare part should be done by a technician by hand without using any tools. This not only makes maintenance faster and easier, but also eliminates the possibility of accidental mechanical damage or short circuit with a screwdriver. All parts that a person can take with their hands during maintenance, move, twist, remove, are painted green, light green. This color even received a special name, OCP green. Therefore, servers from different manufacturers are very similar to each other. but this is a big plus during operation. Working with the equipment becomes intuitive. At the same time, there are no decorative elements here, only what is needed for reliable operation and convenient maintenance. And in its own way, it is very beautiful, such beauty of functionality as an AK-47. The only exception to the tool-less service rule is switches. The OCP rack often houses classic 19-inch switches. It should be remembered that switches are installed here ports forward, and therefore the airflow should be directed from the ports to the power supplies and not vice versa. All manufacturers now have such modifications. The power supply connects through a standard 230-volt socket on the back of the power shelf. A very simple 19-inch adapter is used to install the switches. The main actual computing building block of OCP now is the Tioga Pass server. Tioga Pass is the general name for the form factor and specification within which several manufacturers, including our company, release their servers. Tioga Pass contains 2 Intel Cascade Lake processors and everything you need for use in a modern data center. This is 12 DDR4 memory sticks, 2 PCI Express slots of the 3rd generation, 4 bays for SATA SSDs, an integrated network interface for 1 gigabit per second, and a slot for an OCP v2. This slot accepts a mezzanine network card with a bandwidth of up to 100 gigabits per second. The 3 Tioga Pass servers are housed in a common 2OU passive chassis that only provides power and mechanical support. OCP uses software-defined SDS systems to organize data storage. The data is stored on an external SSD array, the so-called JBOF. Like the server, the 3 arrays are housed in a 2-unit chassis that provides power and hot swappable drivers. One array can accommodate up to 16 NVMe drives, that is, 48 drives per chassis. The connection to the server is carried out via a PCI Express retimer card, which presents disks directly to the server operating system via 16 PCI Express bus lines at maximum speed. As a result, we installed a set of computing tools in the laboratory, which, in combination with software, are capable of solving problems from simple virtualization to complex microservice architectures. All this equipment can be viewed and tested live. We plan to constantly expand and update the laboratory equipment park, test its performance and compatibility with various software.
"17 videos is a lot of videos. That's 7 LTTs, a WAN show, clips from the previous week's WAN show, 3 tech links, 3 short circuits, 2 tech quickies, and a carpool critics." So last week we didn't shoot 7 videos for LTT, we shot 6.
Yes.
And you said on Friday that you were going to come in on Monday, which you don't normally do, and shoot the 7th video.
But my kids are on spring break.
Now, Linus isn't in on Mondays. He spends Mondays with his kids. But we can still do some work here at the office to chip away at this number. So now, if you want to go on vacation next week,
Yes.
we need to shoot more than 7 LTTs this week, and it's already Tuesday.
Dear Lord, how am I going to get a personal rig update for Luke?
This week, the writers' meeting didn't happen on Monday, and we can't actually do it on Tuesday morning because we have a guest coming in for an LTT video, which is Luke.
Yeah, Luke's build could take a while depending on if like his case fits a radiator or not and stuff like that.
Okay.
ANEO, just got to do a pickup for Gold Controller and then sponsored Vizio short circuit.
Not sure we'll be able to do all those things today.
Sarah Secret Shopper build.
Okay, we haven't had writers' meeting yet, and only after writers' meeting am I going to know for sure that Sarah Secret Shopper video can happen on Wednesday.
Oh my God, the ultimate camper van thing, is that happening now?
He's going to bring the van right outside, and we can just shoot here, so it shouldn't be too bad.
How is water-cooled PS5 still might not make it? Oh my
That's
God,
we
because
have to
Alex isn't
relax.
even here.
Maybe the water-cooled PS5 can make it. I don't know yet.
But Alex is in Delta today and tomorrow. That gives him Thursday, Friday to water-cool PlayStation 5. Like,
He's not there all day today and tomorrow. So Intel home upgrade for David, we could possibly do on Friday.
Oh, let's do that.
But they take like a whole day. It's only if we kick ass leading up to Friday that we can have room for that. Otherwise, we'll have to do some shorter, easier videos or something.
Can you guys shoot videos while I'm gone?
It depends what they are. If they're all vlogs, that's harder for our people to do than for you to do. So if we have scripted stuff, then like...
It's like 10:15 in the morning on Tuesday and I already have a splitting headache.
Well, let's get you shooting Luke's video and then we'll look at this in greater detail after the writers' meeting after lunch.
And if I'm feeling bad, I can always caress my gold controller. Oh, yeah.
Hopefully Linus and Luke are done shooting by 11?
Let's just have a look here, okay? Well, that can go right there. Easy peasy.
It is now 1 o'clock and they're still shooting.
Are we calling it good enough? I mean, we can keep going, but it almost doesn't matter.
We still haven't had writers' meeting.
It's gonna be cool regardless.
He's so full of
This is not a good start to the week.
Should I make sure this is doable before I set you at it?
I can see your screen. Yeah, I see your screen.
Your face is way low.
Sorry, it's because I'm eating.
Install webcam at dinner table at home, please.
OnlyFans.
The writers' meeting is where leads come in, either from the writers themselves or from the business team for sponsored projects. We evaluate them, and then we assign each writer a project to work on for that week. And it all gets put into Monday so that anyone in the organization can see it and follow along.
As we finish going through people's sections, feel free to sign out and get back to work because I think we're a little tight this week. I mean, this is work, but like, so who does not have something they're turning in this week?
Unlisted so far is Anthony and Alex.
Okay, Anthony's busy. Alex, do you need an easy one to bang out here?
I am also quite busy.
The hardest part of working here is when something goes wrong and then you suddenly just have to pull a video straight out of your butt.
Is the PlayStation happening?
It can, or we can do the silicon shortage one.
Either way, I need to turn in a video because we have 7 uploads to do per week.
So I guess, do you want silicon shortage or do you want water-cooled PS5? PS5 would be more Linus time, most likely.
Let's just do a scripted voiceover as much as we can.
Cool.
Jackery Ultimate Camper Van.
Colin, is the Jackery van shoot in the morning or afternoon?
Let's just book it for morning.
Secret Shopper.
Sarah is really busy this week. It's possible that we could film part of it because it would be a pretty long shoot.
The entire shoot requires Linus?
The entire shoot doesn't require Linus, just the first part of it, to my understanding.
Well, she's going to need some kind of lifeline, so as long as she has someone else, then that'll work.
Vlogs are more difficult to edit than something that's scripted already. It takes a mental strain where you have to just go home and, well, I just watch YouTube or something and just zone out.
Yeah, we need to find a way to de-vlogify some of what we're doing here because it is killing me.
Scripts, guys. Fully scripted videos.
I think we're doing more scripted content these days. I could be wrong. Am I wrong?
Like, I've been here for almost 2 years now. It feels like we're doing a lot of like vlog compared to City Aero.
Okay, Jackery Ultimate, so this is 5, 7, 8 theoretically, but a lot of these are question marks. Holy shit.
Okay, so in the writers' meeting, we found out that Jesse's secret shopper video with Sarah maybe not able to finish this week because Sarah won't have time, but I have a plan. Sarah, am I allowed to touch these?
Yeah.
Are you free tomorrow morning to do that?
I am.
Like
yes.
first thing, like 9:30.
Immediately.
And I've been told that you're super busy, so you just want to do like maybe part of it, and then next week do another part of it.
Yeah.
You basically won't interact with Linus during the shoot at all.
Sure.
Although I don't think it's going to save us this week unless you do kind of finish the whole video tomorrow. Yeah, which is probably just not going to happen.
Yeah.
My plan sucks. So Ed's not here today. Normally I don't need to directly talk to the shooters. I talk to Ed and Ed talks to the shooters, but he's not here. So let's go talk to Brandon.
Ed and James have to figure out how everything's going to go together and how it's going to get uploaded. Ed's the one that has to like tell the editor like, hey, you get to work late, have fun, and stuff like that.
Hey, Brandon.
Hello?
Are you aware of Jesse's secret shopper shoot with Sarah? So my question to you is, where can we shoot this tomorrow morning, like 9:30 to lunch?
We're pretty short on sets. Yeah, it's a little bit crazy to do that amount of like video in one day. For example, if we're doing 3 vlogs, we only have like kitchen set and the build corner most primarily for vlogs.
The 2 parts are different enough that they can use 2 sets. So it's not like you're gonna have to set one up.
One chunk there and then another chunk somewhere else.
If we're setting those 2 sets up, we don't usually take it over for, you know, other shoot. We have the set left there until we finish the video, which is kind of awful. We just, you know, fighting, you know, to grab the set to use.
Yeah, and no hot set, kind of leave it set up kind of deal. Okay. I think we should put it in the study nook.
Okay.
And then maybe we'll just reuse that for Pluth's video.
Sure, that works too. We'll shoot whatever we can with her that day, and then when Linus needs to use it, we can. Cool?
All right, cool. Thanks.
Okay.
Are there any individuals who are more demanding than others?
If I had to pick the most demanding individual, it would definitely be Linus, because he often skirts the system. He'll just kind of run in and take whatever he needs.
So it's Wednesday morning, and so far we've shot 1 LTT. Wednesday is the day that Linus has his weekly merch meetings, which are scheduled from 9:30 to 11, a good chunk of the day. But today, I got a message from Linus saying, I'm gonna be late. I have an impromptu meeting with this construction company at 9:30. That's gonna push back the merch meeting, and he has a call at like 10:30 with the city. I don't know what we're gonna do, man. Okay, he's pulling in, half an hour behind schedule. Hopefully the merch meeting is satisfied with that, because if we have to do another meeting tomorrow, then we'll really be screwed.
So back to the mock-up then. So basically, it'll be like have gold printing on here.
It's like those the plushie from like Jono had. It's pretty bulky.
Yeah, it's pretty bulky.
Okay, so it's 1:45 and Linus is finally sitting down to do the first script review of the week. Script review is what happens when the writer is finished writing a script, but before we shoot it, they sit down with Linus and go through the whole script looking for factual accuracy, flow, is an exciting video, does it have a good intro that's gonna hook you guys, all that kind of stuff. Once it's done, we switch the status of that item to script reviewed, and that triggers an action for our friend Jeff to go in, add sponsors to the script, and then when he's done that, put it onto the teleprompter so we can shoot. Once a script is reviewed, has sponsors on it, and is on the teleprompter, the writer will come downstairs and work with the shooters to complete this, the ready to shoot checklist. This thing exists because Linus was sick of coming down to shoot and finding out they weren't actually ready for him.
We have a process of how to set up aero. There's no big difference between setting up, like for example, LTT aero versus the Tech Quickie aero. That's pretty like structuralized. Is that the word?
Once that's done, and only then, you can send a notification to Linus saying that the video is actually ready to shoot, and he or whatever host there is will come to the set and do the talkie-talkie. Okay, I just got a notification saying that the script review is done, and Linus is out of the bathroom now, so we can attack him. So, buddy, how bad do you want to eat lunch today?
I mean, I'm pretty hungry.
You've lost your lunch privileges, I think. All right, fine. Have your lunch.
I haven't seen this yet. This is awesome.
Now everybody knows LTT is famous for its sponsor segues. We don't always get to do the sponsor read in the video naturally, but when that happens, we film them like this.
210314 pre-roll key site. Didn't I shoot this?
We call it sponsor pickups, and that's what Linus is gonna do right now. It's an annoying thing that's in his schedule that doesn't help me fulfill my goals.
This is gonna be interesting. I have never taught myself how to build a PC before. MSI looks good, but it's also red. And I don't want a red graphics card.
How long did that take?
2 hours, an hour and a half worth of footage, maybe like 5-10 minutes.
Cool, second question. When will you have time to do the second segment?
Next week, I have a lot of big projects that I'm working on right now, so.
So definitely not tomorrow morning.
Yeah, I don't know.
Okay. See you later.
All right.
You're being very proactive. It's like 9:30, Linus just got here and you're already script reviewing. That is exactly what we need to succeed today, because we need to shoot 3 videos today. So Colin,
Yes.
is there going to be time after this meeting between being ready to shoot? Is there going to be a little window of time there?
There will be a small window I will allow you.
Okay, I'm going to use that time to have a meeting with Linus. And then after that, hopefully we can do some script reviews. Alex wants a script review this afternoon. I actually don't know Anthony's readiness level yet, but ideally we can shoot all 3 of these today so that we have the whole day tomorrow to do David's Intel home upgrade.
Okay, can I actually script review now?
Bye-bye.
Okay, so Colin.
Another thing to think about is how all of those videos we're going to make in a week are distributed throughout that week, because we can't make 17 or 18 videos in one day. So a Gantt chart is a good tool for that. Obviously, there's videos that never move. Tech linked is always Monday, Wednesday, Friday. But things like the LTTs, it's way better to spread them out. We can't really do more than 2 in a day reliably.
It's actually a good thing to shoot a bunch of videos all at once, like try to shoot 3 or 4 videos in a day and then allow for Linus to like go do something else. It doesn't actually cause problems for the editing department, because then we just have a bunch of videos and they can be divvied out to individual people.
This week, I've got a stack of 3 on Thursday. Even though we try to avoid this, a lot of the time, a writer kind of starts a project on Monday and is ready to shoot it on Thursday or Friday. So it's pretty typical to see a stack on Thursday.
It's actually preferable to have like a sort of a mound of videos that you can just chip off and do one at a time selectively, rather than having them slowly come in one at a time and somebody has to do them because there's nothing else to do.
I think this is manageable, but you know, if you can shoot 2 on Monday, the rest of the week is so much easier. So today, Linus is doing a thing that he does once a week, which is called float plane lunch. So here I have on the phone, Luke. Luke, what is float plane lunch?
We have a call usually around lunchtime. We talk about Floatplane. He's the CEO of Floatplane, but he doesn't really see the day-to-day interactions of how it works. If he has any input, he can throw it on us at that time, throw in some last-minute changes, which you just know developers love, and just make sure that he's abreast of what's actually going on at the company.
I know he likes breath.
Yeah, perfect.
All right.
Bye.
Bye.
I'm just getting poked in the face.
There's a lot of clicks to end a meeting. All right, it's 3:45. You're not in your office. You did 2 script reviews.
Yes.
They're going to be quick shoots.
Yes.
They don't have any like vloggy bits.
There's a confetti cannon involved in Alex's, but I think we're pretty good.
Okay. And then Colin's ready for you outside.
Oh.
He said that'll only take like 20 minutes.
Okay.
So I think we could shoot 3 before the day is done here. What do you want to do with the rest of your day when you're done shooting it? Like,
I want to sit and wallow in a pool of anxiety.
can I join you?
Before we had like management involved, it was just chaos.
Our ability to communicate is so much better now. Back in the old days, we just used Excel to track all our projects, which was great when there was like 3 of us, but
nobody knew what anybody was doing. Nobody knew what was finished. Like, oh no, we need pickup shots on this video. Did anybody get them? I don't know. Do you know? I don't know. Just talk to this person. They're out of the office.
But with Monday.com, it doesn't matter if you're on your parents' computer or pulled over on the side of the road using your phone.
Things have actually been going like pretty smoothly, all things considered. Like when something's kind of like gone bad, it's been way less bad.
Everyone's updating their projects, all in one place.
We got 3 today. So we got Anthony's C-to-day role. There's a couple little cleanup items, but they can shoot them without me. So we should be good to do David's Extreme Tech Upgrade tomorrow.
What is your confidence level going into that you're going to finish in any kind of reasonable time? How late do you think it's going to be?
It can't be late because I have to go see a house at 6.
You have to drive at rush hour on a Friday afternoon.
From Vancouver.
Well, the good news is David will not be a camera operator this time. He'll be actually helping me, and David's reasonably competent when it comes to like PCs. So, oh, seriously?
No, I'm fine.
Okay.
We only have to build 2 water-cooled PCs tomorrow.
Wait, they're both water-cooled?
Oh yeah.
Are they AIOs?
Oh no!
It's finally happening.
Oh God. Is there like a bunch of furniture for yours too?
No.
Like, is this actual like water cooling?
There's actually only one computer to build. The other one's already built. We just have to add a radiator to the loop.
Okay, we got this.
All right.
Okay, hold on.
No,
I gotta do my like.
Classic.
Hold on.
Oh my god.
What a fail! And that was Thursday, folks.
And camera rolling.
Is test cam all rolling?
Yes.
Yep.
We're in the home stretch now. It's Friday, and as you know, Linus is at David's house in Vancouver doing his Intel Extreme Home upgrade. But we do have a couple issues today. The fact that the Intel Home Extreme upgrade is happening for David, who's a shooter, means that we only have one shooter left over because we only have Andy, Brandon, and David. And then Brandon is actually off-site doing the B-roll for that van upgrade video. They're out in the woods, like, setting up solar panels and stuff. So we don't have any shooters here that are our normal shooters. So not a lot is gonna get shot here today. It's kind of a challenge. So what are the writers doing instead? Well, it's Friday, which means it's WAN show day. And the hosts of the WAN show don't just go off the top of their heads, they have notes in the WAN doc. So every Friday at about 10 a.m., a notification comes up automatically from Monday.com that says, hey, it's WAN Scrum, and that tells every writer to go and contribute 1 or 2 stories, and then I go and look over it, and I reorder the stories from most interesting to least interesting, and then when the hosts get there at hopefully 4:30, and not like an hour and a half late, it's an easy, smooth show, but I have a feeling it's gonna be late today.
This is going to be tough. I've got 5 hours to fix this water cooling and build a completely separate water-cooled system. The bar is going to be pretty low here.
Okay, so I haven't heard from Linus or David or Andy all day, even though I've messaged them. It's currently 4:30, which is when the WAN show is supposed to start. My guess is that they're scrambling to finish, and he hasn't even left Vancouver, so I'm gonna call him. Hopefully someone over there answers.
I'm still here. I'm leaving soon. Okay.
Okay, bye. Did you hear the despair in his voice? And so then the question becomes, do we just push WAN show to be super, super late, or get someone else to co-host the WAN show, which Alex actually volunteered to do. So he walked down here with his stuff, and then he turned around and came back and said, apparently it's gonna be like a 7:30, 3 hours late WAN show. So we'll see if people wanna watch that.
Night. Hey, how are you all doing, ladies and gentlemen? I hope you're having a wonderful Friday night, or, well, it could be Saturday morning by this point. We're a little late, but I assure you it was for a very good reason. We had the one and only David Gauthier, one of our...
Huge thanks to Monday.com for sponsoring this video. If you want to learn more about how their software can help your team, check out the link below.
Do you guys have any idea what's in there? We got fiber freaking networking, 25 gigabit per second. The only problem is that we're gonna need a way faster, not to mention bigger server in order for all of our editors to use it. Thankfully, didn't wanna slam these are very expensive. We've got just that. We are gonna be rolling 100 terabytes of PCI Express Gen 4 storage on a 100 gigabit per second fiber optic network connection today. And it's going to be a blast. Like Save time and money with Storyblocks. Storyblocks gets you studio quality stock video clips for a fraction of the price. Check it out today at the link in the video description. We'll be sliding this baby into our rack soon enough, but before we do, I want to give you guys a quick tour of what Liquid calls the Badger Den. Now, Liquid is a specialist in composable PCI Express infrastructure and high-speed storage, and this is about as high-speed storage as it freaking gets. In here, we've got 2 64-core, 128-thread AMD EPYC server processors, 1 terabyte of 3200 megahertz ECC registered memory, and a whopping 7 PCI Express Gen 4 expansion slots back here, 5 of which are actually full height, allowing us to hook up what Liquid calls the Honey Badger, and then do it 4 more times. That's right, we can have a total of up to 5 of these carrier boards that are each capable of handling up to 8 Gen 4 M.2 drives for absolutely mind-blowing speeds. Man, I feel like I'm on like a cooking show. I got my mixing bowl, I got my ingredients over here, I got my pre-made thing for at the end. We're only going to be assembling one of these, but it's really important to show you guys how they go together because this right here in a storage server is obviously the key ingredient, the storage. Sabrin sent over 32 of their 4 terabyte Rocket NVMe drives, and we chose these ones specifically for a couple of reasons. Number one, we could have gone with 8 terabyte drives, but those use QLC NAND, and in an application like a server, even one that's going to be written to relatively frequently, we don't want to use QLC that's going to wear out faster. Why we went Gen 3 versus Gen 4 is that A, the Gen 4 drives top out at just 2 terabytes per stick, which would have our capacity, and 2, I mean, we can only hook up at most 100 gigabit per second network card and then twin it for 200 gigabit per second. Even running Gen 3 on these things, we're gonna be so far beyond that it's not even funny. So we'd rather have the extra capacity. Man, this is crazy. Like, thinking back to when I built our first company storage server, we had 1 terabyte drives, and they were this big.
Were they SSDs?
No, they were magnetic drives.
Oh, yeah.
It was almost 9 years ago, Jake.
Yeah, geez. It's like one of those.
Da, 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 da. This is our big old heat spreader for this puppy.
Oh, jeez. Just lay it down and then just lay it down. Oh, Jesus.
Look at this! This is 128 terabytes of raw storage. 128 terabytes! It's like a storage sandwich, you know? Without networking though, these are pointless because we'd have no way to access them. That is where this comes in. This is a ConnectX 6 100 gigabit per second network card with not 1, but 2 100 gigabit ports on it. That's right, a total of up to 20 gigabytes per second, and I'm rounding, which doesn't work when the numbers get so big. So it's like 24, 25 gigabytes a second or something like that. It's flipping nuts.
25, yeah.
And I gotta bury it because the half-height slots are way in the back of the thing here. They're in the bottom. You gotta dig them out. You gotta excavate. One of the sick things about AMD EPYC is that because it uses PCI Express Gen 4, you can actually get the full capabilities out of a card like this. If you were using PCI Express Gen 3, your slot would not actually be fast enough to keep up with both of these ports being used fully at the same time. Freaking nuts, right? A PCI Express 16X slot. That's for like graphics cards. While we've got this opened up, it's a good opportunity to show you guys how expansion can be handled a little differently in servers. On your motherboard, all the ports are built in. On this one, actually, it's these interfaces back here that lead to all of the I/O. So this daughter board right here does 2 gigabit network ports. This one right here does 4, but these could easily be swapped out for other ports if the customer wanted a different configuration. And then this last one over here is what Dell calls their iDRAC. So this is our management port, a USB 3 port, and of course, VGA out so that you can hook it up to a display if you really want to. And then back here, look at these puppies. That's not your conventional PCI Express slot, but it definitely carries the same signal, so you can actually take, yes, this guy right here, and that is what wires up to these PCI Express 16X slots that we're using for our storage cards. Network card and, well, one of them storage for our boot drive. Now, we fill it with badgers. We're actually not quite filling it. We could put in one more badger, but there was a limit to Liquid and Sabrin's generosity. The limit was 128 terabytes. I was like, okay. Okay, got a little bit of stress here, okay? Got a little bit of stress. If I break these, I do not have an easy way to replace them.
We could just call Dell, you know?
Yeah.
They might sell some warranties, though.
How about the warranty? Like if something goes wrong, either with the hardware or software?
Well, that went so well, I think I'll do it again. Oh my God, I see what they mean by the cables being fragile. They're not even, there's no connector. What the hell is this?
Look at how small the wires are, too.
What the heck?
Isn't that terrifying?
There it is. Theoretically, that's it. We're ready to roll this thing. Man, this thing's heavy. It's got a handle back here though, so you can just like carry it, right? Oh, yeah. No, see, don't worry. For something that doesn't have hard drives in it though, it's like, it's got some heft. I'm gonna need a hand. So, hey Jake, you ready to roll this thing?
Yeah, I guess.
Is this handle actually a handle?
Yeah, I think so.
I'm going for it. I'm going.
Do you want me to
for
let
it.
go and you just carry it? I kind of want to try.
I mean, I guess we should. It's our responsibility.
Oh, jeez, we're reviewing this chassis, right? All right, okay, go. Oh, what was that?
Okay, you gotta take it.
You can't.
It's too heavy. What's up, L's and G's? Check this out. Look at them pretend to work when we walk in. Look at that. This is it. We're actually doing it this time. This is new Wonic. It's not gonna have 20 terabytes. It's not gonna have 40 terabytes. It's gonna have 100 terabytes of storage.
Oh wow, so we don't have to delete anything ever?
No, that's not what I said. It's gonna have more storage though, and it'll be more reliable. Jake promises.
I
was expecting them to be more excited. Hey David, watch this. This is the world's fastest server.
Imagine if he tripped.
Now, this is not his permanent home. That's why there's no actual rails in here. We're actually gonna put it here in place of old Wonic. We never actually deployed new Wonic because we continue to have problems with it. So this is officially, I am christening it, new Wonic.
Wonic 3.
New Wonic.
Wonic, you know what? F it. New Wonic.
New Wonic. See you later, old Wonic. And f you, new Wonic.
Yeah, you knew
that thing was. We already created our storage space, and this is it, suckers. 104 flippin' terabytes. See, it needs a minute here. It's gotta check how much capacity we got. What's my free space? I don't know, there's so much.
Did you tell them what kind of parity we're doing?
Yeah, right, we're running just single drive failure protection, single parity. And the reason for that, hold on. The reason for that is that this server will be doing by-the-minute backups to another local server, and then every probably hour or so, it'll be backing up off-site. So we're not really worried about, like, the drives failing, bricking the data.
Plus they're SSDs, so, like, failures are a lot less common.
Should be fine. Oh yeah, there it is.
100 gigabit?
Holy, wait, is it gonna show me a big number? Now, a lot of people get confused when we show numbers like this. They're like, you can't even get internet that fast. Oh my God, I'm so tired of explaining it. That is not the point. That's not the point. It's a local network. We can get these speeds to local machines. Also, we have 10 gig internet, so like, we're gonna use a significant chunk of that, so, you know. Of course, to transfer those kinds of speeds on the local network, you need some sick transceivers. So these are all of the server end transceivers that we're gonna be using. These are 25 gigabit from fs.com. Massive shout out to those guys. Great compatibility, great performance, and did I mention the price?
So good.
Freaking awesome. So we're gonna plug in these ends, then we're gonna go hook up all the editing machines and we're gonna do a live test. Some problem, adrianducao, production manager for linusmediagroup.com?
Dennis can't seem to access Wonic.
Interesting. Well, hey, good news. We're replacing it right now.
So is it gonna work as well as old Wonic used to work too?
It should work better than it ever used to work.
Oh.
That's the plan.
Okay.
So give me like 10 minutes.
So it should never do anything like this.
I mean,
okay, I don't know about
Jake
never.
is staking his reputation on it,
Yes,
but I don't know if I would.
Wait, I didn't, what? Why are you downloading Beyond Compare? Why don't you just use Cho Easy Copy?
I'm not using Cho Easy Copy.
Cho Easy Copy's so good though.
I love Beyond Compare and I trust it. So that's how this is gonna be. New plan, we're going back to our good friend Cho Easy Copy.
It's so good, man.
Oh, it sounds so stupid. But it's one of the only multi-threaded, just directory, take all this stuff and dump it over there programs. It's actually really robust.
3 gigabit.
And we're getting, I think you need 3 gigabytes a second.
2 to 3 gigabytes a second.
Yeah, so that's like 20 to 30 gigabit, which when you consider that we're plugged into a 40 gigabit network adapter on the old Wonic side.
It's 100, I think.
Is it 100?
Yeah, but it's like...
Either way.
Yeah, it's still NTFS.
And it's like being used right now.
Yeah. We could try more threads.
I think it's okay. I'm
Leave it at 16?
Yeah, that looks pretty toasterific right there. I mean, we maxed out at 3.2 gigabytes a second, 2.4 gigs a second. Dang! Now that's hot. It's acid test time, and I actually like Mark's initial comments, so we're gonna interview him about the performance first.
Yeah, it's not bad.
Okay, so what happens in a multicam clip normally?
So usually what happens is I'll press play.
Yeah.
And then I'll stop, and then it will keep going a couple of seconds,
Oh.
and then it'll stop.
Oh wait, so we actually have a tangible workflow improvement?
I guess you could say that if you want to justify it.
Wow, that actually wasn't my intention. We thought we were just adding like more storage. So this is
And improving latency.
Is this a noticeable difference?
Yeah, I'd say so.
Nice. No, this isn't something that we had tested. We knew the latency is better, but like it's not something that we were like, yes, we know that this will work better.
Yeah, and we didn't know that it was going to have like a very real world, like tangible difference. We were just hoping. It's sort of, but we were sort of mostly hoping for improved stability and then also adding the capacity.
Something that we know from past experience is that when you have like a latency spike in terms of storage access on your remote server, it can cause not just one person's Premiere to crash, but like the entire editing den all at once will just go down. So the tighter we can keep those latencies, the better. And that means both networking and storage have to be as fast as possible.
Does it feel better?
Yeah, it's actually, like I'm playing at half res, but everything actually feels really snappy. And like Mark said, normally when you play a multicam sequence, it'll just run away from you, but yeah, this is actually stopping.
My jaw is like, my mouth is like,
I
but
know.
you can't see it. I just like, I'm like, but you can't tell.
I know, I wasn't even hoping for like an actual performance improvement. I was just like, well, we'll just like show lots of people editing 8K at the same time and we'll be like, yeah, that's great, but hey, it's even better. Yes.
You're not supposed to tell them that, damn it.
Well, what? Any thoughts, Dennis?
I'm playing in full, a new test.
Okay, but that's more of like a system bottleneck. Is this 8K or 12K, Brandon? That's 8K? Okay. Is that 8K red or black magic? Black magic, okay.
It's pretty good. Like, it is also it's a multicam sequence.
Yeah, why is yours handling it and poor Mark's system chugged?
Mark's system always has sucked. I don't know why.
It's only one window. You don't have the actual multicam sequence.
Ah, okay.
Oh yeah, okay, you want to do that? Let's see. Yeah, quarter is actually pretty good. I have multicams here and program.
And remember, we've got everybody else hitting this same project at the same time.
This is on the new thing. I can like go around. Bam, bam, bam. This project is on the old one.
Oh, you've got it up and on both servers right now. What a pro.
Oh, yeah, you see? Look at that. There you go. Oh, wait, it's in full.
Wow, okay, hold on. What?
Okay.
That's huge.
Gotta have that Gen 4, baby, because remember, actually, Hoffman's only testing one aspect of the upgrade right now, because both of those servers are running at 100 gig right now. So that's actually just the Honey Badger, just that Honey Badger power.
Good.
Honey Badger don't give a f***.
He said so many times this video. It's great.
All right, so good job, everyone. Good job, Jake. Good job, editors. Keep at it. Socially distanced fist bump or whatever. So all that's left is to thank everyone who helped with this project. Jake, the editing team, for you guys can actually go back to whatever you need to do now. Thank you very much, guys. Of course, Liquid for providing the server and their Honey Badgers, Micron for sending over their memory, FS.com for all the transceivers, Mellanox, excuse me, I mean NVIDIA for the high-speed networking gear. Man, those cards are so freaking sick. And am I missing anyone? And Sabrent, right, for sending over all the drives, 100 terabytes. It's so fast. And Infinite Cables. Thanks for the cables, guys. And right, our sponsor for the video. Storyblocks gets you studio quality stock video clips for a fraction of the cost. And you can download all the stock video your heart desires from their member library, including HD and 4K footage, After Effects templates, motion backgrounds, and more. We use it quite a bit on TechQuickie, and all the content is royalty-free, so you can use it for personal projects like YouTube videos, or commercial projects like, well, for us, YouTube videos are also commercial, but new clips are added regularly, so there's always something fresh to download, so why wait? Check it out today at the link in the video description. If you guys enjoyed this video, you might enjoy the more in-depth look at both our high-speed networking as well as the high-speed storage with the honey badgers that we did with that server as a preview to this. Those were theoretical though. I'm really glad that it's actually working once we deployed it.
Woo! All I gotta say is new Wannick.
You mean new Wannick? Oh no,
No,
yeah,
no, no, yeah.
new Wannick, yeah,
Yeah.
new Wannick, that thing. New Wannick, that's where it's at.
Wannick 3.
New Wannick.
So, what's up guys? It's Grant here. Today is a new introduction video to a new project I am very excited to talk about and start here. It is the Cybersecurity Home Lab project, and I'm going to be giving a brief overview of what we will be doing, or what I will be doing, in this project. So, for the longest time, I have been wanting to create what some people have coined as the term home lab. The purpose for me is to simulate and emulate a corporate or enterprise network, setting up different technologies, systems, and managing those systems through a centralized service like Active Directory. I'm going to be deploying and configuring all kinds of services, including what you would see within an enterprise or corporate network. Now, of course, this isn't going to be the scale. This is going to be a super small scale, but it's going to help me introduce myself to really just configuring and doing some sysadmin type projects, and then adding the security onto that. To see what I'm talking about, I have a diagram that I've created for this project, which I'm going to briefly overview. Alright, as you can see here is the Cybersecurity Home Lab project. I've created this graphic to give me just a bit of clarity on what I want to do within my home lab project. Now, of course, everything is always subject to change, and things can be scalable, so you can do and add different things. But this is the base project that I will be working on. So I have an old gaming PC that I used to use for gaming, of course, and I'm going to be using this as my centralized server for my home lab. I'm not going to be doing it through this Windows laptop. I will be doing it through a main PC for other reasons, just because I want to offload and try different things. I'm going to be doing a few different things. First thing I'm going to be doing is configuring and setting up this main PC, and then also be working with setting up a Linux desktop VM and a Windows 10 Pro or Professional or Enterprise, and I'm going to be connecting these and managing everything centrally through Active Directory. So I'm going to use Active Directory on this main PC and connect several VMs to it to simulate workstations. And then I'm going to be configuring an RDP server or desktop. Because RDP is such a popular service used on a corporate scale and level, I'm going to be configuring and learning how to secure RDP properly. I'm going to tuck this behind a Palo Alto Panos 8 image VM, just because it's an added layer of security. And then as well, I will be working on building out a VPN server, a vulnerability server, which will be an image of Tenable Nessus, the vulnerability scanner, and a SEM, and I will be using Splunk as my SEM. All of these will be hosted up in VMs as well. And then I'm going to be creating a pfSense VM to get me a little bit of more experience working with open source firewalls. So I'll be working with both a Palo Alto and a pfSense image, and I will connect this to the main PC, and everything will be filtered through the pfSense firewall to my home router, which will go out into the internet. The reason why I want to do this specifically is because I don't want to mess around with my other family members, and I just want to segment everything off, provide network segmentation for this home lab. Now you may be wondering how exactly you can follow along as I document and learn throughout this process. Well, basically everything is going to be hosted up in a VM or within VMs or virtualized. So besides the main PC that I will be dedicating to this home lab, and I'll call this a server, you can basically do everything else from just a normal workstation as long as you have the processing power. So there really is no constraints or hardware things that you have to buy to follow along with this project. All you have to do is just, you know, follow along with your virtual environment and workstation. So let the project begin. Hacking. No, I'm just joking. I have a document that is hosted out on my website detailing a little bit more about the cybersecurity home lab, including all the resources I will be using to learn throughout this project, maybe more sources as they go. I'll be documenting this whole process on my website, cyberacademy.org, so make sure to read about the following details or what I'm learning in addition to these videos. Of course, I'll link those as I go throughout the project. I hope this is going to be an interesting, project for me to learn, simulate a corporate network, and I hope to learn a lot. Yeah, I hope you guys can maybe use this as well as me. So, until the next time, you guys have a fantastic day. lives. So, what's up guys? It's Grant here, and I will connect this to the main PC, and everything will be filtering is going to be or hardware.
Welcome back, so I'm Techno Tim, and today we're going to take a tour of my home lab. As a quick reminder, I stream every Tuesday, Thursday, and Saturday, so if you want to continue the conversation about home labs there, we can. So let's talk about home labs. In my past videos, I've hinted that I've had a home lab. I mean, it's pretty obvious that I have a home lab. I mean, I'm making tutorials about home lab apps to help you self-host some services at home. And throughout all of these tutorials, I've sprinkled in screenshots of my home lab, whether it be my Proxmox servers, some of my network setups, my Raspberry Pis that are also running some workloads, but I've never shown the complete tour of my home lab. I've always felt that I'll show it when I'm ready, when my home lab's mostly complete. But what I realized is that home labs are never complete. They're never totally ready, and they're always evolving. And so after I tweeted out a few pics of my home lab and posted it on YouTube, you guys have asked to see my home lab quite a bit. No, like really, you asked a lot. And so I decided that today, we're gonna actually walk through my home lab. And so I'll walk you through my home lab and network setup, but it's obviously not in here, it's in the basement. So let's go down there. Okay, we'll start off with my network rack. Now, as you can tell, this really isn't much of a network rack, but it does serve a purpose. I think most people's networking equipment starts off with kind of humble beginnings and then kind of grows, and that's what this did. This is something I built myself, so when we moved in, I didn't have any networking equipment, and the easiest way was to build my own. I've always mounted my cable modem on the wall. It's always worked better than just putting it on the shelf. But you can see that I totally built this myself. I took some 2x4s, some plywood, I painted it, mounted to the wall, and then mounted everything I could to it. It's a little messy right now, especially the cords up top. But having everything in a dedicated place sure has been helpful, and it's helped organize some of the cords as well. The power on the top isn't the greatest, but it serves its purpose. It's kind of out of the way and all the cords are tucked in behind. And then you can see down below, I actually have this little umbilical cord coming out the bottom, and that's this sleeve, this cable management sleeve that I bought that actually works out pretty well. You can tuck all your cables in there, zip it up, and tidy them up. So let's take a look at each of these things individually. First, this is my fiber modem. It supports up to a gigabit up and down, which is super nice. We're fortunate enough to have gigabit here in my area, but I only pay for 300 up, 300 down. Saves me 20 bucks a month, and I never really use that much. So that's where my internet comes in, and we'll skip over my switch and go to my patch panel. So this is a patch panel right here. I put this in, most of this stuff I put in about 6 years ago. So this patch panel right here is a trip-light patch panel. It's only Cat 5e, but that's all I needed to get gigabit. So I'm a huge fan of wired networks. It's not that I like networking, it's just I like the throughput on wired versus wireless. I wired most of my home with Cat 5e. That included a lot of crawling around, cutting holes in walls, accidentally cutting one of my radiator pipes, and then pulling them all down to here. It definitely wasn't fun, but it was so worth it. So this is only a 12-port patch panel. It kind of serves its purpose. Everything from my house comes into here, and then I have jumpers over to my switch. So this is my Cisco switch. It's an SG200 18-port. They're all gigabit. It's a smart switch. So it has 18 ports. They support 10, 100, 1000, so gigabit Ethernet on all the ports. It also has these mini GBIC ports, but I don't really use them. And it is a Cisco switch, so you get everything you would expect on a Cisco switch, most of which I don't use. So then coming off this switch goes down to this little switch. This switch is a TP-Link switch. It's an 8-port gigabit switch, but it also has 4 ports of PoE. So I really needed the PoE to power some of my cameras. I have PoE cameras all over the house and outside, and so this delivers the network and powers some of those cameras. It was super cheap, it's unmanaged, and it gets the job done. And then you'll see I didn't have a great way to mount this, so I just found these tie straps, bent them, screwed them in, and painted it. So next, this is my HD home run. So this is an HD TC2 US. It's a dual tuner, so this gives me free over-there HD TV. I can watch and record TV in 1080p, and it helps me cut the cable. I haven't had cable for probably 10 years, and I've been running some type of DIY DVR for quite some time. I mean, I was running Windows XP Media Center Edition. That's how long I've been doing DVR on a PC. So this records tons of TV. It connects to Plex, and this is how I watch all of my PBS. Okay, so then we'll go right above. So this is my Philips Hue hub. This Philips Hue hub controls all of my Philips Hue devices. So that controls a lot of light bulbs. So it controls the color temperature, as well as the brightness. And you'll see those lights when I'm streaming or recording. Those are all Philips Hue, so I can adjust them. So I can have my light mode and my dark mode. And they're also paired with the Hue Play. Sometimes I'll turn it on for games, but for most of the time, I just turn it on for a backlight for monitors. Okay, so on this rack, last but not least, this guy, he's pretty important. So this is my Pi Zero. It's a wired model. It's not the wireless. And it has a USB network adapter. So I have a USB adapter that's over here. And so this USB adapter goes from USB to mini USB into this Pi Zero. And this Pi Zero is using one of the cases I put on all of my Raspberry Pis. It's the Zebra Zero case by C4 Labs. It's really awesome. It's clear, looks like ice, and has black, and it's really well constructed. Every Raspberry Pi I have, I buy the Zebra Zero case for it because they're just so fantastic. But this Pi Zero only has a few jobs. Really, it just keeps my home network running. So I wrote some shell scripts for it. All it does is it just pings my servers. If they don't respond, it'll send a wake on LAN packet. So it'll try to wake them up with a magic packet and then ping them again. If they don't respond, it'll keep doing this. Eventually, it'll reset its own network adapter and then reboot itself. And it just does this all day long. And this is just to make sure that my servers are on. Now, I don't know about you, but sometimes you have power outages, and I have UPSs, but every now and then my servers could go down, and this is the little guy that keeps them both on. Super cheap and a great use for a Pi Zero. And so yeah, this is my network rack. It's pretty humble. It started from nothing and grew into this. Eventually, I'll rack all of this in my server rack. But for now, it's on the wall, it's off the ground, it's not on shelves, and it runs really good. And I hope this is a reminder just to let you know that, hey, you don't have to have a network rack to actually build out a network. You can do it with some cheap stuff from Home Depot and Amazon. And although it doesn't look the greatest, it functions really well. So this is my server rack. This is a SysRax 18U 4-post open frame. So I assembled this myself. It took about 3 hours to put together. It's super heavy and super solid. It holds everything I need right now, plus it has an additional 6U that I can expand for later. Plus, I might downsize a few things, but we'll get into that later. But I like it, it's great to work on, it's very open, air can pass through very easily, but at some point I might figure out how to add some panels and maybe add a door to it. But I'll figure that out later, and if not, I'll just try to find one on Craigslist or eBay, and then repurpose this one for something else. But this is great for now. Okay, I'm gonna start at the bottom. So the bottom is my UPS. This is the TripLite 1500 VA Smart UPS battery backup. It's running right at about half capacity, which gives me 10 minutes of battery time. And this is plenty of time if the power goes out to actually shut this down. So I've never had the power go out longer than 10 minutes here yet since I've had this UPS, but it's definitely helped with all the brownouts and power surges that we've had here lately, as well as all the thunderstorms that have been shutting the power off for just a couple of seconds. So this does have a USB cable that I can plug into my server, and then I can shut it down if I'm running on battery power too long, but I've yet to hook that up. I probably should do that. Okay, I'll just work my way up the rack. So next, this is my NetApp disk array shelf. This is the DS4246. I got it off of eBay and it's fantastic. So I got the model that ends in 6. That's because it supports 6 gigabit on the SATA speeds. And as you can see, if you couldn't tell from my social media post, I finally added some labels to this. It was kind of a nightmare trying to figure out which drive was which when I was having problems, but I no longer have that problem. So as you can see, it can hold up to 24 drives, which is really awesome. This gives me a lot of room for expansion later on. But for now, I've only populated 6 drives. So I have 6 drives in here. They're the 8 terabyte Seagate Iron Wolves. They're made specifically for NAS, and they've been running pretty good so far. I did have some problems with 2 drives that were throwing some errors, but Seagate quickly replaced them and shipped them to me ahead of time. So that was really awesome of them to do that. And so you're probably wondering, what does the connection type look like from this to my server? Well, it's connected via an LSI HBA external SAS PCIe controller. So this gives me an external SAS interface that I can connect using QSFP to a mini SAS. It was kind of challenging finding the right cable, and they're kind of expensive. But this disk shelf so far was totally worth it overall. Okay, working my way up the rack again. So this is my Dell R710 server. I bought this server on Amazon refurbished. So this is a fantastic server if you're looking for some old enterprise retired gear. This one right here is pretty much maxed out. And the reason why I bought it on Amazon is because this one actually had a warranty on the whole entire server. I know I could have gone to eBay and partied it out all individually, but honestly, I really didn't want to put in the time to track everything down individually and then put it together and hope it all worked. So yeah, I picked it up on Amazon and it works fantastic. But anyways, yeah, it's almost maxed out. So it has dual Xeons, X5670s, and they're 2.93 gigahertz. So each Xeon has 6 cores plus hyperthreading. So that's 24 logical cores. So you get 12 physical and 12 virtual. It came with 144 gigs of registered ECC RAM, so that's pretty much maxed out. And then in here, it also came with 6 2 terabyte drives, but I outgrew them rather quickly. So I've replaced all 6 of these with 500 gig SSDs, and they're in a RAID 10. So it did come with a RAID adapter, and I'm using that RAID adapter to do a RAID 10, so RAID 1 plus 0. So that gives me a Stripe plus parity. And all of this SSD storage is for my virtual machines. Oh, and also, this right here, this is not the optical drive. So if you press this button, it's not gonna work. So the optical drive used to be there. And I found this really awesome drive caddy that you can replace your optical drive and put in another solid state drive. That's the drive that runs the OS, which this is running Proxmox. So if you have a server and you have an optical drive and you aren't using it, I highly recommend getting a caddy and putting another hard drive in there. So this Dell server also came with the iDRAC, the integrated Dell remote access controller, and this allows me to connect to it remotely if it's shut down, allows me to flash the firmware, and I can even reinstall the OS remotely by mounting an ISO, but I don't use it that often. But it's nice knowing it's there and I can use it if I need to. So this came with a quad gigabit NIC, but I've also installed another dual gigabit NIC that my network firewall uses for the LAN and the WAN port. But that's pretty much all this server does. It runs lots of virtual machines and very fast. And most of that hardware is passed through to the guests. Okay, next up the rack, this is a Chenbro rack mount 4U server chassis. So this doesn't really look like enterprise gear, does it? This is actually my old gaming PC that I converted to a server. So this case is really awesome. It's a 4U rack mount, there's lots of room, it has 8 full height expansion slot. It also has a front panel here, too. And if you haven't noticed, there's like a freaking laser beam shooting out the front. You don't want to look directly in this because it's super duper bright. But I have front panel access to buttons, has some blinky lights, USB, all the normal stuff you would see on a PC case. It has a fan right here too and a filter that I can clean out, but there's not that much dust here in my basement. Okay, so let's take a look inside. All right, so here's the awesome thing about this case. So it's pretty much a PC inside of a case. So for reference, this is my old server. This is the case that I removed all of this hardware from. It's the Corsair Air 540 High Airflow ATX Cube case. It's a super nice case. It's all black, it's pretty sleek, has a nice window, lots of room for drives, lots of room for customization, and great airflow. And it has dust filters. So if you're planning on building a NAS or a server sometime, you could get something like this. It's great if you're just starting out. So yeah, I took all of that hardware and transferred it into this case. So back to this Chenbro case. It's really great, super roomy. I bought it used and it didn't come with any fans. It should have came with a fan, so Amazon refunded a little bit to me, which was perfect because I just replaced it with some Noctua fans. So those fans back there are 80 millimeter Noctua fans. And then I have a 120 millimeter fan up here, and that's Noctua as well. So about this build, this is my old gaming PC. So this is the Intel Core i7-4790K. So this is the Haswell. I think it was codenamed Devil's Canyon. It has 4 cores, 8 threads, So for a long time, this was one of the fastest stock clocks you could get on a core. And it turbos up to 4.4, but that's not really needed. So this processor supports VTX and VTD, so I can virtualize things and actually pass hardware through. So this is all plugged into my ASUS motherboard. This is the ASUS Z87 Pro. It was a premium board at the time, and it also supports VT-D, which is nice, and it has some pretty quality components. You can see all of the nice heat spreaders, and they're nice in gold and black. And so this turned out to be a nice little server build. So in here I have some Samsung 500 gig SSDs for my VMs, and I used an adapter to get them in the 5.25 bay. And if we look back there on the left, you can see a pair of video cards. So this one right here is the MSI GTX 1050 Overclocked Edition. And you can also see it doesn't draw any external power, and that was on purpose. So really, I just needed the NVENC encoder off of this card. This is the older NVENC, it's the Pascal architecture, but it's perfect for what I needed to do. So this actually runs the 24-hour Mixer stream. It's always on. RIP Mixer. So now that Mixer isn't around anymore, I'll try to figure out something to do with this card. Okay, so to the right, this is the Zotac Gaming GeForce GTX 1650 Overclock. I also use the NVENC encoder on this, but this has the new Turing architecture. So this one right here runs my Twitch stream. It's a 24-hour always-on stream. And you can tell on this one too, it does not require external power, which was on purpose. Both of these draw all the power they need from the PCI Express slots. Okay, and then you can see here is my RAM. So I just have 32 gigs of DDR3. And that's really all I need for this server. This server only runs 2 virtual machines. Each virtual machine has a video card passed through it. And then I assign 12 gigs of RAM to each, which is plenty for these virtual machines. And this is my second Proxmox server. So I hope you enjoyed the tour of my home lab. It's nowhere near complete, but most aren't. And you can see in my home lab that it's been an evolving process. I started out building my home lab thinking it was going to go one way, and then I needed to make some drastic changes and start racking in a rack mount server. And then I converted old PCs to rack mount cases and rack those. So I'm kind of in between from where I was to where I want to be. But I hope that shows you that not everything needs to be buttoned up before you try. I felt that way for a long time before sharing this video with you, but I realized sharing it now might be the best thing to do, so that in the future I can go back and look at this and say, hey, this is how it was, and this is how it is now. So what's next for my home lab? Well, I'd like to get a rack mount patch panel. I'd love to run all my network cables down to that patch panel. And then from there, I'd love to add a 10 gigabit switch. I'm kind of holding out for RJ45 and copper, but we'll see how that goes. And then from there, who knows? I may scale down, I may scale up. But that's the beauty of home labs. They evolve as your needs evolve. So in case you didn't notice, this was just the physical setup of how my home lab is set up. In a future video, I'll walk through all of the software and services that are running on each machine so that you can understand the types of workloads that are running on that hardware. And if this is something you'd like to see, let me know in the comments section below. And while you're in the comments, don't forget to give this video a thumbs up and consider subscribing if you haven't already. So thanks so much for watching, and till next time, stream on, my friends.
Yeah, so that's kind of like my intersection of things I like, you know. It's this tech plus hosting and sharing plus gaming. Like, that's my wheelhouse. I mean, that's half the reason why I started this YouTube channel, is because of just that. But yeah, so same thing with like my Discord bots. Like for me, that's like totally like, I love it because it's like, I get to build a Discord bot, it's writing code, then I get to host it in my own infrastructure, and then I get to share it, and then it's in my server. So, and it's in the gaming genre. So yeah, so I don't know, gonna give it a spin. We'll see how it goes.
For a system like this, you ideally want ECC memory, but unfortunately this doesn't support registered ECC memory. Because of this, I hopped onto eBay looking for a RAM kit that would fit my needs and budget. What I ended up getting was 4 4GB sticks of crucial unbuffered DDR3 RAM running at 1066 MHz. These 4 sticks cost a total of around $43, which is an okay deal for unbuffered ECC RAM. 16. What's going on, guys? My name is Matt, and for a while I very badly needed a new data storage solution. See, up until this point I've done what a lot of content creators do, which is fill up my internal drives, then either delete files or move them to an assortment of external drives. This works okay, but it makes it hard to track down certain files, and there's no redundancy, which isn't great. Going for something like an off-the-shelf NAS can cost hundreds, if not thousands of dollars before you even begin to factor in the cost of drives. Hopping onto YouTube, you'll find people who claim to have built a high drive count system for only a few $1,000s, and then they proceed to pull out $10,000 worth of drives provided to them from a manufacturer. This is fine and all, but I wanted to see what I could put together for much cheaper. So say hello to my new 80 terabyte storage server that I put together all in for right around $1,500 bucks. It's got an 8-thread Xeon CPU, 16 gigs of RAM, 80 terabytes of raw capacity, SSD cache, and more. Now, just a disclaimer, I'm a huge server noob, so don't take this as a guide, and actually there is a bit of a glaring issue with the hardware selection in the system, which I'll talk about later in the video. So the idea for this server all started when I saw a craft computing video on a 1U 12 drive server that cost under 150 bucks. This seemed like what I was looking for, and I kept coming back to this video until I decided to track one of these down and purchase it. Going onto eBay, I found a number of these Chenbro NR12000 servers with various configurations. After some deliberation, I landed on purchasing this one for $120 with free shipping. This server had pretty much everything I needed besides RAM and drives. I ordered this one, and a week or so later a box landed on my doorstep. Opening it up, I found the surprisingly compact system suspended in a bunch of close-cell foam. This made me super happy to see that it was so well packed. Pulling out of the box, the only other thing I found was a power cable, and pulling it out of the foam, I was ready to open it up for the first time. Loosening this thumb screw right here allows the huge top panel to slide forward, then be pulled off. Inside, you can see around 40% of the space is taken up by the server components, and then the whole other section contains mounting spots and cables for up to 12 3.5-inch drives. In terms of core specs, the CPU this came with is the Intel Xeon E3-1230V2. This is a 4-core 8-thread CPU running on the Ivy Bridge architecture. The E3-1230V2 has a base and boost clock of 3.3 and 3.7 GHz respectively. This is a bit overkill for my current use case, but I may be able to take advantage of it in the future for stuff like virtual machines. This CPU is being cooled by an all-copper passive heatsink. This little guy is surprisingly heavy for how small it is. With no fans on the heatsink itself, it means it gets all of its airflow from the 40mm fans placed towards the middle of the case. There's also this thin plastic shroud that ensures 3 of the fans blow directly onto the heatsink and RAM. The motherboard the system uses is on the LGA 1155 platform and is made by a company called Tyan. It has 4 RAM slots, a bunch of PCIe slots which aren't that important because of the system's 1U form factor, but would be good in a more standard thickness case. The I/O on this board is 4 USB 2 ports, dual gigabit Ethernet ports, an IPMI port, VGA, serial, and a UID LED button. This isn't great for a normal system, but for a server this selection of ports is fine. The real feature of this board that makes it perfect for this use case is the 14 built-in SATA ports. This allows all 12 of the main drives to plug directly into the motherboard, leaving 2 more open for extra cache drives or even redundant OS drives depending on the configuration you go with. Powering the system is a 400-watt, 80+ gold rated Flex ATX power supply. This unit is purpose-built for a server like this with tons of SATA power connectors. One downside of this server is that it doesn't have redundant PSUs, but that's fine for me. Now there are 13 total SATA power and data cables pre-run to each of the 12 drive slots and one to a 2.5-inch slot for an OS drive. What's really nice is they're all labeled, which is amazing for troubleshooting and finding a problem drive within the array. This labeling can 100% be done in any system, but having it pre-done saves a ton of time, and for a noob like me it's extremely helpful in keeping a project like this from being overwhelming. All these parts are in the 1U enclosure, which is pretty compact considering how much hardware can fit in it. With the server picked out and received, I could start figuring out and ordering other parts. For a system like this, you ideally want ECC memory, but unfortunately this doesn't support registered ECC memory. Because of this, I hopped onto eBay looking for a RAM kit that would fit my needs and budget. What I ended up getting was 4 4GB sticks of crucial unbuffered DDR3 RAM running at 1066 MHz. These 4 sticks cost a total of around $43, which is an okay deal for unbuffered ECC RAM. 16GB is an adequate amount, especially for the configuration I ended up with, and luckily they installed and worked flawlessly in this system. With RAM picked out, all that was left to do was purchase drives. I did a bunch of thinking and planning to get drives and was waiting for good deals on higher capacity drives, but with the looming possibility of a drive shortage due to Chia mining, I eventually decided to pull the trigger on 10 8TB external Seagate drives. See, normally you would buy standalone drives, but believe it or not, it's cheaper to buy the external versions and take the drives out of them. This practice is known as shucking and is very common within the data hoarding community. Again, I originally wanted to get something like 12 or 14TB drives, but I couldn't find a good enough deal, so again purchased 10 8TB drives at an average of $125 each. This totals to $1,250 spent on mechanical drives for the array. I also purchased a 500GB SATA SSD to be used as a cache drive. This is the crucial MX500, which is a good quality SATA drive, and I'll be explaining more details about using it as a cache drive later in the video. With all the drives in hand, I could begin shucking. Opening up the packaging on one of these drives, I found the drive itself, some paperwork, a USB cable, and a power cable. I started by taking each of the drives out of their packaging and plugging them in to ensure they powered on and reported normal functionality. Once this was done, I could begin opening them up. One thing to note is that taking the drives out of the casings does void the warranty, but these drives are much cheaper than their standalone counterparts, so you have to decide for yourself if the cost saving is worth it or not. To get into these enclosures, you need to start by wedging something super thin like a razor blade into the seam like this. Then you can wedge something slightly bigger into place and begin to pry up to release the clips. It's very difficult and may be impossible for a normal consumer to open these without breaking any of the clips, and I definitely left most of these with numerous broken ones. With the top popped off, I could then do a little prying to get the drive out. Then I could pull off these rubber shock mounts and unscrew these metal pegs. With that done, I could unpeel this metal foil, flip it over, remove this screw, then remove this board. This little board is just a SATA to USB adapter, and I may save these to use in the future. With one drive done, I then had to repeat the process 9 more times, and here's a little time lapse of me doing it. So with all the drives out, I was ready to mount them. Now when shucking external drives, you never really know what you're gonna get. Most of the larger capacity Seagate external drives use Iron Wolf NAS or even Exos drives, which are super high quality, and one of the reasons I originally wanted to go for the larger capacity ones. Inside of these 8TB external drives were 10 Seagate Barracuda Compute ones. These are model number ST8000DM004. And I got these for about $30 less per drive compared to buying these standalone drives, meaning I saved around $300 buying them as external ones. This is when I came to a very important realization. These are actually SMR drives. SMR, or shingled magnetic recording, is an inferior and outdated design which is very unideal for certain use cases, but with them all shucked, I had to proceed with the build, and in the end it worked out fine for my use case, which I'll explain in a minute. To mount these, I needed a few things that didn't come with the case. I needed these little rubber gaskets that I got off of Amazon, and some 6/32 bolts that I got from my local hardware store. The gasket slips over the bolt, then one is secured into each of the 4 bottom mounting holes on the drive. I installed 4 into each, meaning 40 bolts and 40 gaskets total. The first one was brought to mount number 1. The SATA data and power was plugged in, it was lowered down, and then slid back to secure all 4 gaskets into place. With the first one done, all I had to do was install the other 9 drives one at a time into mounts 2 through 10. With that completed, the last component I had to install was the cache drive, which is in mount 11 and currently not secured, but I will probably mount it with some double-sided tape in the future. With that done, I need to decide what kind of OS and file system I'd be using with this. I originally debated between TrueNAS Core with a ZFS RAID Z2 file system, but because of the way ZFS stripes data across the array, my research shows that SMR drives would not be good to use in that kind of setup. This made the choice to use Unraid much easier. Now, Unraid is paid software, but it's ridiculously easy to set up and gives a good alternative to RAID or ZFS, which are the more common options for a file server like this. See, instead of data striped across the array of drives, each file is only stored on one drive, and you set up parity drives for data protection. This means accessing files only requires one drive to spin up, making for a quieter, more power efficient, and less drive stress intensive setup. While this does all sound great, it comes with the caveat of having much less performance when compared to a RAID 6 or ZFS RAID Z2 setup. With normal write speeds of around 30 megabytes per second, it can be painfully slow to transfer files. With that being said, that's where the cache drive comes in. When transferring files to the server, they first go to the cache drive at a faster rate, then at a later time, say in the middle of the night, you can use a mover script to transfer them automatically to the array. For me, this is great because it means a ton of archival storage that should be reliable and low maintenance, but the slow speed means doing stuff like editing directly off the array isn't possible, which again is fine with me. Setting up Unraid is very simple, and I actually followed a guide by Juan M. Tech, who did a great job of explaining the basics of how to set it up. I'll go over the process briefly in this video, but we'll link the tutorial in the description. Unraid actually is installed on a USB drive, and then the OS is loaded into RAM anytime the system boots up. All you really need is a USB drive that has a few gigabytes of capacity. I actually ended up using this 64 gigabyte drive because it's the most compact one I own, and may eventually clone it to a smaller capacity one. It's important that it's physically compact because it will be permanently sticking out of the back of the server, and the lower profile the better. So to set the USB up, I just downloaded the Unraid USB flash creator, opened it up, named the server, then installed it to the flash drive, and this whole process took like 2 minutes. I then plugged it into the server and booted into the BIOS. The only monitor I have with VGA is this dying one, so please excuse the poor picture quality. I set the boot priority to the USB drive, then saved changes and exited. It booted to this window, then automatically loaded in the Unraid OS. It did an initial setup, then provided an IP address to access the server remotely from any web browser connected to the same network. I then went into my browser and typed in the IP address that was provided and was brought to this page. The Unraid version I need will be $90, but I just started out with the trial to make sure I liked it. I then proceeded to assign the first 2 drives as parity drives, the other 8 as part of the array, and the SSD as cache. I then had to build the array and configure the parity drives, which for 8TB parity drives took around 16 hours. This isn't ideal, but is pretty normal for the size of this drive. Then I formatted the drives in the array, then set up a root password, created a share folder that I will access over the network, created myself a user account that can read and write to the share, and finally mapped the network share to my file explorer. Once that was done, I had access to the full array. Once parity drives were taken into account along with the overstatement of size by drive manufacturers, I was left with around 58TB of capacity. This amount of storage should last me a minimum of 2 years and likely at least 3. Getting back to the drives used, SMR drives have their major downside in rewrite performance from my understanding, so if you're constantly adding and deleting files to the server, it's definitely not ideal, but anything I put on this server will more than likely never be deleted, which means this problem shouldn't affect me. Again, if you're doing a project like this, try and avoid SMR drives and go for CMR instead. All in all, for around $1,500 in hardware, this 80TB storage server is pretty sweet in my opinion, but I'm very interested to hear your thoughts on it in the comments below. I'm a server noob like I said before, so if there's another way you think I should configure this, or certain plugins or features I should enable, let me know. All the parts and resources mentioned in the video will be linked in the description. If you guys have any questions, I'll try and answer as many as I can. So yeah guys, I think this wraps this video up. I hope you guys enjoyed it. If you did, make sure to give this video a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.